Hey guys, this is Mr. Grice for Algebra 2 Unit 3.1, 3.4 Review B. Remember to show every step and to write your answers on the lines. Whoa, wrong direction. Okay, so let's go ahead and look at number 1. Now, I got an equal sign here. I've got to solve. I've got to figure out what the absolute value is. What is y? Now, I can't solve it right away because the absolute value is not by itself. So to do that, the first thing we have to do, add 10 to both sides. We get -9 times the absolute value of 8 plus 4y equals 98 plus 10 is 108. Now, is the absolute value by itself? Nope. Right now that -9 is multiplying, it's times the blah, blah, into the absolute value. So to get rid of multiplication, we have to divide, and 8 plus 4y equals, let's get our calculator here. I have a positive divided by negative, so that should tell you something right there, but it's 108 divided by -9, and we get -12. Now, can an absolute value equal a negative number? No. Okay, so our final answer is no solution. All right, number 2. Same thing. We want to get the absolute value by itself. So I'm following SADMAP. I got to add the 6 to both sides. I get 7 times the absolute value of 8 minus x equals 21. Now the absolute value is not by itself yet, so I have to divide both sides by 7. And I get the absolute value of 8 minus x equals 3. So when the absolute value equals a positive number, I know that we're going to have 2 solutions. Okay, so what we have to do is break that down. We're going to have 8 minus x equals 8 minus x equals, and I set that up to a -3 and a +3. And then we solve them both. Okay, I'm going to pause the video and I'm going to let you guys solve them on your own. Good luck. You'll need it. Actually, I hope you don't. Okay, so we had to add or subtract 8 to both sides. And then did you remember to divide by -1? All right. Well, that gives us our final answer of x equals 5 or 11. All right, it looks like this one we get to solve it and graph it. I'm super stoked. But just remember, same thing, even though we've got an inequality here, we're still doing the same thing. We have to get the absolute value by itself. Okay? So to do that, I'm following the order of operations, the inverse order of operations. So I have to subtract the 8 to both sides. -4 minus 8 is a -12. The absolute value is not by itself, so you can't say no solution yet. I have to divide by a negative, and when I divide by a negative, my sign changes. I get the absolute value of -2 plus 4w is greater than 2. So the absolute value is by itself, and it's going to be a greater. So we know that it's going to be or. We set up the -2 plus 4w, -2 plus 4w. One of them stays the same. And remember, the other one, you have to flip the sign and make it negative. A lot of people forget that second step. Okay? So what do? Well, we solve. I add 2 to both sides. I get 4w is greater than negative 2 plus 2 is 0. Divide by 4 to each side. We get w is less than 0. Or I do the same thing to the other side. Add 2 to both sides. 4w is greater than 4. Divide by 4. And we get w is greater than 1. And this is what we're going to use to graph. All right, I'm just going to come over here. I'll zoom out so I can see it. But at 0, we are open, and I'm going to shade to the left. At 1, I'm open, and I'm going to shade everything to the right. So when I write that in interval notation, we start at negative infinity. Oh, not negative 8, negative infinity to 0. I'm open, there's a break, and then we pick up again at 0, and we go all, or 1, and then we go all the way to positive infinity. All right, so I'm just going to write that on our line for interval notation. All right, there we go. Let's just keep moving along. All right, I'm going to zoom in, and we're going to look at number 4. So we have to graph and answer the questions. So the first thing we talk about, is there a reflection? Yes or no? Yes. Okay. There's a reflection, which means it's going down. So that's where I take a look at that 3. What that 3 is telling me is that I have to go down 3 over 1. Okay, and the last thing we need to know is, what is our vertex? I take the opposite of 2, which is negative 2, and then the 4 stays the same. All right, so here we go. At negative 2, 4, there we go. And we have to go 1, 2, 3 over 1. 1, 2, 3 over 1. And I'm going to do that in both directions. Okay, I'm going to fix that point because it doesn't look good. And there we go. Make sure that you're using a straight edge when you're graphing. Okay, I'm getting my straight edge out right now. And oh, we're going to redo that. Okay, and there we go. All right, so let's see what the questions ask us. What was the shift? Well, we pretty much did the shift already when we found our vertex. My first number tells me to go left 2, and then we had to go up 4. Now, was it stretched or did it shrink? Do you guys know? Well, this one stretched, and it stretched by 3 units, and I'll prove it to you right here. Because, yeah, that was the rate of change. See how we go down 3 over 1? That's our stretch. We stretched 3 units. All right, let's move on to the next one. Number 5. Is there a reflection out there? No. No reflection. It's going to be going up. So, what do? Well, we have to go up 1 over 3 because that's what our rate of change is telling us to do. And then our vertex, it's going to be negative 1, negative 5. Okay? And look, technically we can do both of these now, but I know that I'm going to have to go left 1, down 5 for my shift, left 1, down 5, and then I'm going to go up 1, 1, 2, 3, over 3, up 1, 1, 2, 3, in both. Oh, I can only do 2 points over there. Okay, so did this graph stretch or did it shrink? I can't hear you. You might have to say that a little bit louder. Yeah, it stretched. No, it didn't stretch. It shrank. Come on now. So yeah, it shrunk, and it shrunk by 1/3 because we have to go up 1 over 3 to get to the next point. So remember our normal one is just 1 over 1, and it didn't get skinnier like our last one did. It got wider. All right, number 6. Is there a reflection? Yep. That means we're going to be going down. Now, what's the number out in front? There is no number, so that just means it's 1. So we're going to go down 1, over 1. And the last thing is our vertex. I take the opposite of what's inside, which is just 0, and the number on the outside stays the same. So my only shift is going up 5. All right, so I go up 5, and then I'm going down 1, over 1, down 1, over 1 in both directions. Once again, I'm using my straight edge to draw my lines. Hopefully you are too. Line it up. And there we go. All right. Oh, that arrow doesn't look very good. Neither of them did. Ay, ay, ay. Okay. So, was there a stretch or a shrink on this one? No. This one, there's none. The 1 over 1, that's like the parent function. Okay? All right. Let's knock this out in one video. Go ahead and flip it over. Okay. So, I want to know, where are we increasing and where are we decreasing? So what we do is we look at the left versus the right side because our vertex is the middle. Now from left to right, our left side is going down and the right side is going up. So the side that is increasing, well, that would be from -4 because that's where that vertex is, all the way to positive infinity. And let's make that look a little bit nicer. Okay, so that means we are decreasing on the left side. So that means we are decreasing starting at negative infinity, and then we stop decreasing at -4. Okay, so now they want us to find the average rate of change between those two, what? Yeah, these two x values. So at -3, we're right there, and -1, we're right there. Oh, sorry, that's not -1. There we go, there's -1. Okay, so how do I get from one point to the next? Well, I have to go up first. I went up 4 over 2. Okay, so if I were to come up here and say, well, I went up 4 over 2, well, that reduces to 2 over 1, which is the same thing as 2. All right, do you think you can handle number 8? Give it a try. Go ahead and pause the video, and good luck. Okay, so the left side was increasing, that's negative infinity to 2. So we're decreasing from 2 to positive infinity. And from the x values 3 to 6, our average rate of change was a negative 1 over 1, or negative 1. Alrighty, more fun stuff. Now, number 9 with the domain. Remember that domain is that's the x, okay? So from left to right, horizontally, are there any breaks in our graph? No. So that means we're going from negative infinity to positive infinity. Now range is the y. That is our up and down. Now it might be kind of hard to see, but our graph actually does have a stopping point, and that's all the way down there at negative 6. I can't be below negative 6, but I start at negative 6. So that means my range starts at negative 6 and then it goes on to positive infinity. All right, and now we're really going to zoom in here. So I want to know when we are above 0. So I'm just going to cross all this off because I don't really care about it. When is this graph above 0, this function? Well, at 1 I'm above, and I'm above everything to the left of 1. And I'm above at 5, and I'm above at everything right to 5. So if we were to write this in interval notation, I'm above 0 from negative infinity to 1. There's a little break right here, and then I'm above at 5 to infinity. Okay? That's all the times that this function is greater than 0. Okay? So from negative infinity to 1, there's a break, and then it's from 5 to infinity. Okay? So the next part, when are we below? Well, we would be below from 1 to 5 because that's when our graph, this function, that's when it drops below 0. Okay? So that would be from 1 to 5. Okay? So all we're going to do is just do the next one. All right, once again, our domain from left to right, negative infinity to positive infinity. Our range, now we're at the bottom. It's going to negative infinity for sure. But then where does it stop? Because it doesn't go to positive infinity. It stops at 5. Okay? And this one's different. Where are we above this time? Well, I'm above from negative 4, sorry, I can't see it, to 2. And this is where I am above 0. Okay? So I'm going to go ahead and write that in. We're above 0 from negative 4 to 2, which means from negative infinity to negative 4, I am below, and from 2 to positive infinity, we are below. So negative infinity to negative 4, there's that break, and then it picks back up at 2 to positive infinity. Okay, almost done. 2 more. You have to write the equation for both of these. All right, so the first thing that I notice is that it is flipped, which means there's a reflection which means when we start it off, it's going to be negative. There's my vertex. What is my vertex? Well, I had to go left 2, and I had to go up 4. And then the next thing we need to figure out is what is our average rate of change? And I go 1, 2, 3. We went down 3 over 1. So negative 3 over 1 is a negative 3. So that's the number that's out front. We have x. I take the opposite of negative 2, which is positive 2. And my 4 stays the same. Okay, so f of negative 3, when f is negative 3, remember what we were doing there? Well, they tell us the x, so I can draw a vertical line. Sorry, so I'm trying to remember how I taught this. X equals negative 3. So when x equals negative 3, here's my line. Dunk, there we go. What is that point? And that is the point negative 3 comma 1. So when x is negative 3, y is 1. Find the value so that f of x equals negative 2. I don't know x, so that means they told me the y. So y, let's make that actually look like a y. So our y equals negative 2. Y equals negative 2. I'm going to draw the horizontal line. Find my 2 points. And those are the 2 points of negative 4, negative 2, and 0, negative 2. So we would say it was negative 4 and 0. Sorry, negative 4 and 0. Okay. Think you can do it? Pause it. Let's figure it out. Good luck. Okay, so we get y equals 2/3 times the absolute value of x minus 1 minus 4. Remember, we take the opposite of the negative 1, or opposite of positive 1 to get to the negative 1, and the negative 4 stays the same. Find f of negative 2, that means x equals negative 2, so when x equals negative 2, y actually equals negative 2. And then find the value of x. This, I'm only saying it singular because there's only one answer, and it was when y is 1, and that number looks weird, so I'm just going to do it over. And it was nice we already had that because that was our vertex. All right, guys, well, guess what? That's all she wrote. That's the end of the review, so that means, yep, quiz. There's going to be a quiz tomorrow or whatever day this is in the future for whatever year we're watching this. Okay? If you need help, come see Ms. Carranza or myself. We would love to help you out. Otherwise, this is Mr. Grice signing off for Algebra 2, Unit 3.1, 3.4, Review B. Thanks for watching.